You know how we do. Right. Hold on. Let me see if I can play with with who's that boy? My Google Meet. Right. How about now? We good now? All right. All right. I see in Salome. I see in Gabe. I see in Anne. All right. Folks, good evening. All right. Wait, did I put stuff? Yeah. Oh, yeah. We are recorded. Oh, wow. Yeah. Totally spaced on that there. Diana Sudney. All right. How you doing, Diana? All right, folks. Good evening. So hopefully today we're going to wrap up the May 2024 paper 2. So we're on to question 9, the geometry and trigonometry question, which is a very popular one. Right, so we have a diagram here. So clearly it's the circle theorem question. So we have V, X, Y, and Z lie on the circumference of a circle shown below, center O, with diameter Vy. Right, so that part there. So hold on. So V, X, Y, and Z lie on the circumference center O. So O is the center of the circle. And what they are also saying is that Vy, which is this line here, is a diameter. Now a diameter cuts a circle in half. Half a circle is called a semicircle. And the angle in a semicircle is 90 degrees. What I mean by that is that, like here, if we were to build a triangle on that diameter with these two other green chords here, the angle here would be 90 degrees. Right? So that angle there is 90 degrees, the whole thing. All right? So that's a diameter. Now, it says that further, right? Further, it says, come on, man, Philip Davis, I don't want no tags. Not that. Right. Oh, no, the wrong thing, man. It's doing this thing. All right, cool. Right, that's fine. So it says UW is a tangent to the circle at V. So UW is this blue line down here. Right? Now, a tangent is a line that touches a circle at one and only one point. And we have a couple of rules. So this piece here, OV, is a radius. What's the rule about the angle between a tangent and a radius? It's equal to 90 degrees. So we have a 90 degree on that side and a 90 degree on that side there. All right. Now we also have another rule about angle between tangent and chord. All right. So what is that rule? Anybody remember? The angle between a tangent and a chord is equal to the angle in the alternate segment. Right? So this line here is a chord. Right? So the angle between tangent and chord, which is at angle A, is equal to the angle in the alternate segment, which actually is this angle here. And on the other side, so let's get a different color going. Right? Because this line here is also a chord. So the angle between tangent and chord is equal to the angle in the alternate segment, which is actually, hold on. Yeah, that's this angle here. What's that? That's too much pressure? Oh, okay. All right, well, yeah. No need to put unnecessary stress on yourself, but sometimes it may not be very important. Life is about simplifying sometimes. Right. So some of these rules, I mean, you should know these rules offhand. If you don't, it's not a big problem. But, I mean, you have time. Now, in terms of time, let's just remember, right? By Saturday, we're in March, right? March has 31 days, April has 62 days. And then what's the date of the exam in May? The 9th? Well, yeah, mock there. But the actual thing. Was the date of the actual exam? Do you remember? No, English is the 6th, that's a Monday, right? Accounts is the next day, which is the 7th, and I think 2 days, the 9th, right? So let me just do this. Right, so like we were saying, So Monday's the 5th, sorry. Accounts is the 6th, that's the Tuesday. And then 3 days after, so the Friday is the maths. All right? So, yeah. So if you're 61 and 9, well, it's not even a whole 9 days you have. That's 70 days. That's 7 days, 10 weeks. Well, it's on the last paper. You mean the multiple choice? Oh, well, it's multiple choice. Yeah, why not? It's multiple choice. Anyhow, right, let's go back to the paper. Okay, cool. So it says, state a theorem that justifies the values of each of the following angles. Okay, so they want to state a theorem why angle B is equal to 62 degrees. Where is B? B is here. Okay, let's take out some of the colors that we have so we can see things a bit more clearly. Okay, so sometimes what helps is let's thicken up some lines here, right? So where do we see another 62-degree angle anywhere in the question? Where's that? By angle, by X, right? And if you kind of let's highlight or overlay those lines so we can see the rule a little more easily. Right, so that's why you could call it the dead butterfly. Well, please don't call it that. That's just how I read. So the dead butterfly rule, the Deadpool rule, Spider-Man rule, or what is the correct thing? Angles in the same segment standing on the same arc are equal. All right. Right. If you wanted to talk about the same chord, right? And if we block out right, block out that one. Right, so those two, right? As a matter of fact, let's put that one on a different color, right? Oh no, I need that slightly heavier point. Right, so we have the kind of pink triangle built on the green base and a blue triangle built on the same green base. So when you have in a circle, when you have a chord, right, that green chord, and it's the base of triangle, you can build triangles on that base, and they touch the opposite circumference, right? The angles at the circumference are equal to each other, right? And the proper, I guess you could say, phrasing of that rule is that the angles in the same segment standing on the same arc are equal. The arc to which they're referring is this orange arc here, right? So standing on the same arc or built on the same chord, right? So if we were to build another triangle, let's say at that point there, right? This angle would also be 62 degrees, right? If we were to build even another triangle, right, here, right? So notice all those triangles have the same green base. So once they have the same base, right, and they are touching the same circumference, right, the angles at the circumference would be equal, right? But the phrasing for the rule is that angles in the same segment standing on the same arc are equal. All right, so yeah.
When you're done, do you have any questions on functions?
Yeah. So what I could do is I could see if I could put it up on a laptop and send it there, right?
Yeah.
Right. So angle B is 60 because angles in the same segment. Wow, what is going on with my writing today? Angles in the same segment standing on the same arc. Sorry, one sec. Cool. Oh, hello YouTube. Hello 4 viewers on YouTube. Hope you're all well. I don't really watch the comments. I will try to do so. So if I don't respond right away, please don't bear me any ill will. Right. Angles in the same segment standing on the same arc are equal. Right. So we'll take off the extra lines here. Okay, cool. All right. Hey, pretty happy. You know how you do it. All right. In class, people, are we okay with that first one there? Why B is 62? Any questions? Anybody? Anything? No? All right. Google Meet, just give me a quick G. All right. So only has 60 also. Aisha, D'Angelo, Donovan, Juliana, Liam, and Logan. If you guys are good, give me a G. If you need me to re-explain, it's not a problem, right? You know how you doing. All right, cool. Now, why is angle C 124 degrees? Okay, angle C. Let's see if we can see angle C. Oh, all right. So let's take off some of these extra lines here. Okay, so I see an angle C in the middle. In the center. Okay, all right. So here we're gonna do. Let's outline the rule, right? All right. So that. Right? And when we see that, what rule comes to mind? That's the what I like to call the arrowhead rule, the Star Trek rule. The angle in the center is double the angle at the circumference, right? So if we blank out some of the extra lines here, right? So that might make it a little easier to see, right? Hey, Chelsea, how you doing? Casey and Jane, evening. Right. Yeah. So angle C is the angle at the center, and it's double the corresponding angle of the circumference, which is 62. And double 62 is 124 degrees. Right? So the angle at center is double the angle at the circumference. All right, so 62 by 2 is equal to 124 degrees. Okay, in class, people, are we okay with the item in the green there? Any questions, problems, anybody, anything? No? All right. Google Meet, you know the drill. If you guys are good with that, click G in the chat. I could scroll back up if you want to see. Right, now we have more questions based on the same diagram. Right. So what I'm going to do, I'm actually going to send a picture of this diagram in the chat. But I think what we'll do is we'll probably solve for those same angles on this page, if anything. So I might copy and paste this page. All right. All right. Cool. So let's get a little. So that's the question there. Just crop out a couple of things, and then we'll scroll down and send the solutions we just did, right? Yeah, I feel like that one ought to crop much. Okay, so let's check out the part 2. Right, so it says here, oh, sorry, we forgot one. Why is angle OVW 90 degrees? I think we answered that one earlier on in actually the first thing we did, right? Angle OVW. So whoa. No. Yeah. So OVW. Right, so OV is a radius and VW is piece of the whole tangent. And we said earlier the angle between tangent and chord is equal to, tangent and radius is 90 degrees. All right. So, what is this, right? So, okay, now I had to go back to a lighter point on it, right? So, the angle between Tangent and radius is 90 degrees. Okay. Right. So just so you know, they want us to find the other unknown angles, A, D, and E. All right. So I'll be going back to that one. Yeah. Well, which one are you doing? Right. Which what you want? Which part of part you asking? Bearing. Well, you could use the first part to do that. Right. The bearing of P from S is 205. So you just had that. You just had to subtract 180 from 205. You get 25. I'll show you just now. I'm gonna get there. All right. All right. So my online people, we're looking for A, D, and E. So A is down here. D is here. And E is here. All right, so I'll give you a few minutes. I'm gonna just go and take a little quick walk around and see how people are doing, see if you need some help, and then we'll correct those things shortly, right? So they want the values of those three angles, A, D, and E. Any bearing, any initial bearing that's less than 180. Let's say the bearing of B from A is 120, right? If you want A from B, you add 180. Anytime the bearing is more than 180 degrees, you have to subtract 180 to get the radius. Bearing more than 180.
For X1 and now drop the Y. You want to retry? Yeah, I'll retry. That's what you do it is when you're given all things for X by Y. Okay, we do 4X Y minus 1 by Y. Yeah, okay. Sorry. Doesn't work? Yeah. Okay, I'm gonna write this X cross off into Y. And it's I'm gonna divide my second.
All right, sorry guys. I'm just taking a little walk and seeing who needed help. And I get type on a question. Yes, circle geometry, that's correct. I do not know how to pronounce that. I'm sorry. I would say Persia or Passion, but I don't wanna. Chad, hey Chad, what going on? I'm seeing there, boy. Well, assuming this is the same Chad was part of my class. Jada K. Marie. How you doing, Jada? It's the steel. Alright, okay, cool. Let me organize some stuff here, right? Okay. So A, D, and E. So we could go in order if you want. All right. All right, but let's put in the items that we kind of previously worked out. So we're not working blind, right? So this angle here was 62 degrees. We found that a bit earlier. All right. We also know that this is 124 degrees here. We know that this whole angle here is 90, as is this one here. And we also know that this whole angle here is 90 as well, because that's the angle in a semicircle. All right. So we have to find a few things here. Now, A is actually 62 degrees, and I'll tell you why. A is 62 because this is a chord, and this line here is a tangent. And the angle between tangent and chord is equal to the angle in the alternate segment. So A is 62 degrees. All right, so that's that fluid. So let's go and write that down and come back. Right? So A is 62 degrees. All right, and again, it's because it's the angle between a tangent and a chord, and that's equal to the angle in the alternate segment. All right, so let's write that down in the next page, right? So angle A is equal to 62 degrees, right? And that's because it's the angle between tangent and chord. Is equal to the angle in the alternate segment. Okay, so that's our first one. Now we're gonna just backtrack for a second, and now we're gonna check out. Oops, if it'll. Let's see if it comes back up. Oh, there you go. Oh, hi guys. Right. Let's check out angle. So okay, so sorry. This was what? This is 62 down here. All right, so that's 62. Sorry, my bad. 1 second. Be yourself. All right. Okay. All right. So now we want to find angle D. Right. Now check this. Right. O is the center of the circle, and if you notice, angle D is actually kind of. Oh, come on, man. Be yourself. Yeah, angle D is actually kind of. So you have OV, which is a radius, and OZ, which is also a radius. Because both of those are straight lines that start from the center of the circle and go to the circumference. Oh, thanks for sharing live. Ha 11, not sure, right? And you have it, it's closed up with a chord here, ZV. So you have an isosceles triangle because it's a triangle built with two of the radii in the same circle. Would you subtract 62 from 90? You could subtract 62 from 90, right? And that will give us the angle here. That's correct. And because it's base angles of an isosceles triangle, this is also equal to angle D across here. So yeah, so it will be 28 degrees. That's correct. Right, that's one way to do it. Very good. Cash. Right. So you could do that, right? The other way to do it is to take, because we know that this angle here and this are equal because they are base angles of the isosceles triangle, we could take 124 from 180, right? Because the angles in a triangle sum to 180 and then divide that by 2, right? 124 from 180 is 56. And 56 divided by 2 is 28, the same as 90 minus 62. So let's put both workings on the next side. All right. So let's start off with a green. I know I didn't work in green just now, but all right. Okay, cool. So this would be equal to, so okay, we have, let's do 180 minus the 124, then divide by 2, right? So that'll be 56 divided by 2, which is equal to 28 degrees, right? And you have two reasons, right? You have that angles in a triangle sum to 180, and then base angles of an isosceles triangle are equal, right? All right, sum to 180. It means they add up to 180 degrees, and base angles of an isosceles triangle. Right, and then the other way to do it is as, come on, man, just behave yourself. Just behave yourself. Right. Right, would be to say 90 minus the 62 is equal to 28 degrees. And again, here you have two rules, right? So one rule is that angle between tangent and chord, tangent and radius, is 90 degrees. And again, base angles of an isosceles triangle are equal. Sorry for this crappy writing. Let's get words from the zoom in. All right, cool. Right. Okay. So that's A and D. So Google Meet, just give me a quick G if you guys are good with those first two. These and tax. All right. I'll do the third one, but I forgot I was supposed to ask one by one because I know circle geometry can be a little iffy for some people, which is perfectly normal. Don't feel how about that. Right. 1, 2, 3, 4. Right. So just a couple people to tell me what's going on. Aisha and Juliana. All right. Thanks very much. All right. And item E now. Let's take a look back here. Right. So item E, I think the easiest way to find this. Right. So check it. We just found that this was 28 degrees here. And then what's going to happen is this angle here and this angle here are equal 18 because the angles in the same segment standing on the same arc, right? And if we add up all three of them, we get 90. So if you take 28 and add it to 18 and then subtract it from 90, you get E. Right? Right? So let me just run through that one more time, right? So again, we wanted to find angle E, right? Now, how I saw it was that I said, okay, look, we know that the whole angle here, is 90 degrees, right? We just found that this piece is 28. So if we could find this angle here, we could add that to the 28 and then subtract it from 90 and get the value of angle E. Is there a simpler way to solve for E? That's a good question, boy. If we could find this angle here, we could add it to 62 and subtract from 180 to find E. Alternatively, if we could find this angle here, we could add it to D and to this D and subtract it from 180. But I'm not sure how to find either of those simply, because either of those we still have to use the 18. Right? If anybody wants to volunteer, that's not a problem. Yeah, but to me this one not so bad, right? Because again we have a 90-degree angle here, and you already have this piece which is 28, and this piece is 18 because it's equal to this piece across here. Right, so 28 and 18 is 46. 46 from 90 is 44, actually. So angle E is equal to 90 degrees minus, what was it? 28 plus 18. Right, so we could put a little 1 here and a little 2 here. Right, so that's 90 minus 46. That gives us 44 degrees. Right? Why it's 18? Why it's 18? All right, because, one second. Let's get rid of all the excess stuff here, right? So if we block out that, no, actually we don't have to block out that one, but we could block out that one if you want. That one, and again, you just kind of identify the shape / theorem that you're working with. Right, so that one, right? So it says that angles in the same segment standing on the same arc are equal, which means that these two angles are equal and these two angles are equal. That's why it's 18 degrees there. All right, hope that helps. Right, so the two rules I have to cite here is that, right, so rule 1 was that, well, actually we talked about rule 1 already. That was actually at the top of this page, right? The angle between tangent and radius is 90 degrees. Oh, actually, that's not the rule we're using. We're using angle in a semicircle. Oh, okay. Right, so the angle in a semicircle is equal to 90 degrees. And let's put in the proper notation for that. So that's actually YZV. YZV is the angle in semicircle. Right, so that's the angle YZV. And then the second rule is that with 18 degrees is angles in the same segment standing on the same arc are equal. So that's actually, this angle here is YZX, and it's equal to YVX. So YZX is equal to YVX. Angles in the same segment, ... Yo. She's coming now? Okay, no problem. Segment, ... are equal. Right. Okay, cool. So we're gonna send it to class. You got it? All right, cool. Oh, thanks for the follow. All right, Google Meet. If you guys are good with that orange one there, just give me a quick Genie chat, please, and thanks. All right. If you need me to re-explain, that's not a problem. Just let them know. All right. All right, Julie. All right, cool, no problem. There we go again. All right, so give me 1 sec. All right, so Julie, 2 things, right? All right. Yeah. So that's the diameter. Right. Let's blank out some of the other lines, right? Julie, I'm gonna blank out this line here. Well, I tried. Yeah. Just remember, I'll go upstairs and get the money, right? Yeah.
Are you able to print out
That's a little tricky.
That's okay. Oh yeah, because everything's happened around.
Yeah. No, but that's a good thing. What we need to do is get you set up on the hard drive and give you access to the stuff. All right.
Cool. For the class tomorrow, I'm taking the questions for the mix of questions from day 6 and day 4.
That's fine.
Okay.
That's fine.
Okay.
Yeah, no
Because
problem.
only 2 days out, we didn't. Well, we would have left off last one day 5, and day 4 was when nobody came.
Right. Yeah. Yeah. No. Well, yeah. So it's a good thing we had the extra days to kind of wrap it up
so
then.
she's doing much better.
Okay, cool.
It's just
All right.
kind of confusion. I think once I actually laid it out to them, because I think it was like confusing at first to see it separate, like differentiation.
It does. Yeah.
Integrations, but I kind
Well,
of feel diagram
unless-
the same words, when differentiation is just
Yeah.
integration.
Unless you were tacking it onto the end of differentiation and integration,
Yeah.
then you need to do it separately first because doing two different things
At the same time,
could
like
cause
a
yeah.
lot.
So you do it two different ways and then tie it together.
Yeah.
So yeah, that's fine.
But yeah, she did well.
Perfume
Yay.
under. Hey, thanks very much. All right, cool. Okay, so Juliana, we seeing the 90-degree angle there, as in the angle in the semicircle, right? Because remember, O is the center of the circle, and the line YOV is the diameter. The diameter cuts the circle in half, and when you build a triangle on that diameter, the angle at the circumference is 90. So Julie, just give me a quick G if you're good with that first part there. The angle in the semicircle is 90. Right, okay, cool. And then when we follow it up with this piece now, right? We have the other one where the angles in the same segment standing on the same arc are equal. So this angle here was equal to this angle here. So this angle was 18 because this angle was 18. Are you okay with that one? Okay, cool. Right. So we also know from a previous part of the question that this angle here was 24, right? Because that was 28. My bad. It was 28. Right? So we had that from before. So right. So if the whole angle is 90 degrees, and we have a 18 degree portion here and 28 degree portion here, we could find the last piece of it by adding the 28 to the 18. 28 and 18 is 46, and then subtracting that from 90 degrees. So does it make a little more sense now? Is it clearer now? Saturday is the 1st of March, yes. Okay, all right, Julie, good. Thanks for letting me know. Okay, all right, cool. So let me go again now. So that was it for the circle geometry question, right? One of the slightly more fun aspects of the whole maths paper, to be honest. Patterns question and circle geometry, yeah. Okay, so ladies and gents, we're looking at hold on, did I send that in the chat? It's 7:26. Okay, cool, that's fine. Yeah, we have time, but we had to move with that time. Okay. Take a read. All right. So the diagram below shows a quadrilateral PQRS formed by joining two triangles, PQS. So PQS is one triangle, and then QRS is the next triangle. All right. So PQS was the left-hand side, and QRS is the right-hand side. All right. Calculate the length of QR. That's this piece here. Now QR exists in a triangle where we have two of the adjacent lengths and the angle between. So if you remember, so it's not a right angle triangle, so we can use basic SOHCAHTOA, but we know we have sine rule and cosine rule. And this is a perfect setup for sine rule, right? So if this is S, this is side S, and that's what we're looking for. If this is R, then the opposite side is side R. And if this is Q, the opposite length is side Q. All right? And so for cosine rule, right? So we'll call this right? So S squared is equal to Q squared plus R squared minus 2QR by the cosine of angle S. All right. So plug and play. And yes, cosine rule, that's correct, right? You know your stuff, man? Oh, it's three things you sent. A heart, perfume, and dog. Well, thanks very much. That's very generous of you. I almost never get stuff. Thank you.
Yeah.
All right. Oh, right.
Yeah, that's
Okay, hold on. What's going on?
She's kind of worse than Syria.
I understand shit here. But you're kind of jumping in the middle of stuff. Good night, Chantal. How you doing? Good to have you on. All right. Right, guys. So just to kind of recap, if we have a triangle and we have two of the lengths, we have the measure or the magnitude, and we have the magnitude of the angle between them, what we call the included angle, we can use cosine rule to find the length of the unknown side, which is opposite to the only angle we have. Well, in this case, the only angle we have. Right? It's the angle between the two adjacent sides for which we have the length. So let's plug it in, right? So again, it's 3 marks, but you don't have to write too many things, right? You write your formula to show, hey, I'm using the cosine rule. Then this would be equal to, so Q is 16. So we have 16 squared plus 18 squared minus 2 by 16 by 18 by the cosine of 25 degrees, right? The next thing you write could just be the solution to that thing, but just be careful how you plug it into your calculator, right? So I don't know why the calculators on the computers on science, well, it says scientific, but it's anyhow, 16 squared plus 18 squared minus brackets 2 by 16 by 18 by the cosine of 25 degrees, right? So 57.9 blah, 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 right? 57.9 dot, dot, dot. So therefore, if that's s squared, to find s, we have to find the square root of that. So you keep the value in your calculator and you simply find the square root of the item. So 7.61 approximately, right? 7.61 meters, correct to 3 significant figures, right? Remember, there's a standing instruction on the front of the paper that says non-precise or non-exact answers, rather, should be shown to 3 significant figures, or in the case of angles, 1 decimal place. All right? Okay, cool. Let's zoom out to here and send a picture in the chat. All right. Okay, so Google Meet, just give me a quick G in the chat if you guys good with that one item there, please and thanks. All right, lovely. Thank you very much. Okay, cool. 1, 2, 3, 4, 5, what is it? Right. I don't like this topic very much. Yeah, this one could be a little off-putting, right? What's that? That's cash. But it takes a little finessing, right? But it's worth the effort to be able to figure out stuff like that. All right. Okay, and then let's go back across here now to the last part. Okay, the bearing of P from S is 205 degrees. Determine the bearing of R from S. Bearing of P from S is 205. The bearing of P from S. So the first thing is we need a north line at S, right? The bearing of P from S is the clockwise angle between the north line at S, the starting point, right? And then the line joining the 2 points. I hate circles theorem, but I love circles theorem. Where did you use something in the papers of 2024? Where did I find them? They find their way to me. People will send them to me. So I just get them. I don't really have to look for them. Right. So what they're saying here, so once again, the bearing of one point from another is the clockwise angle between the north line at the start point and the line connecting the 2 points. All right. So this entire pink arc here is 205. Right. Now, they want the bearing of R from the same point S, which actually is this piece here. So if you zoom in, right? Sorry, one sec. I'm trying to zoom out a little bit. Right. Right. So check this. If the entire pink angle is 205, right? Sorry, I thought I switched back to pink. Right. The whole thing is 205, right? And we want the green part of it. Right. So technically speaking, if you take the green and you add, so let's get some more colors going, right? So the green plus the blue piece plus the, sorry, I thought I switched to orange, right? Plus the orange piece, right? Gave us the whole pink arc. So correct, added and subtract, right? So do we have an in-depth video on this topic on your channel? I have recordings from my past classes, which you could do cash. Email me, chris@adaptuition.com. Let me see if I could sort you out, all right? Okay, all right, Paige. So go home, feel better, rest up, and come back on Wednesday, right? Come back before you go punchy. Yeah? All right, cool. So yeah, so that's correct. So what we do is we add 72 and 25, and we subtract that from 205. What was it? It was 25 on what? 72, right? All right, so of course that's 97. Right, so 205 minus 9. So 205 minus 97. So that's the same as 100 minus 3, right? So yeah. Well, yeah. So you could minus 100 and add back 3. Long story short. So 205 minus 100 is what? 105. Add back 3 is 108. 108. Anybody got 108? Yeah? All right, cool. And then the bearing of S from P. Right. So the bearing of S from P is what I like to call the reverse bearing. Right. And we have a couple of little shortcuts that we learned when we did bearings back in early January. Right. If the initial bearing, so let's call it B1, is less than 180. Right. Less than or equal to 180. Right. If you want bearing 2, which is the reverse. So let's say the bearing of, so let's say it's, bearing of 0.2 from 0.1. right? The bearing of 2 from point 1, right? If that bearing is less than 180, and you want the bearing of 1 from 2, as in you want to flip the bearing, all we do is we take the first bearing, 2 from 1, and we add 180. If, however, if the bearing of 2 from 1, as in the second point from the first point, is greater than or equal to 180 degrees. No, not equal to. Yeah. Right? And you want the bearing, you want to flip the bearing, 1 from 2 instead. So you take that first bearing of 2 from 1 and you minus 180 degrees. In the email. Yeah. Yeah. So this bearing is 205, right? The bearing of P. So hold on. So give me 1 sec. Now I'm gonna go back in the diagram and explain it, but give me 1 sec, right? The bearing of P from S, which is what they gave us on top here, is equal to 205. So that falls in the green category, right? So what that means is that the bearing of S from P is equal to the bearing of P from S, which is 205, minus 180 degrees. So that's equal to 25 degrees, right? Now, that's the shortcut. So supplementary angles add up to that. Yeah, you could use that too. That's correct. Right? I'm going to go back. I'm going to go in the diagram and explain, right? So again, if you know your shortcuts from whenever, you could always do it there, right? However, if you don't know your shortcuts, but you understand the basic principles of what a bearing is, right? What you do is you go to your diagram. Your diagram. Okay, if it would zoom out, that would be great. Ah, that's great, man. Yeah, lovely. Okay, right. What we do. Okay, you know what I'm gonna do? I'm gonna actually copy and paste the page. Right. And what I'll do is I'll erase everything here. Right. Okay. Let's zoom in. Right. Okay. Right. So let's see what. Oh, come the man for them to do that. Right. Right. So this, okay, let me actually, I'm going to color out those angles there, right? Hey, behave yourself, no man. Right. All right, so it's colored out there. All right. Okay. So then we'll see you next 2 weeks then, because next week, Tuesday is Carnival. All right, later. Enjoy. Right. So sorry. So this whole angle here is 205 degrees, right? Okay. And what they want is they want the bearing of S from P, which is this angle here, right? So as somebody was saying here, what we could do is, again, you just draw, sorry, I need to get that a little heavier. Right. We're going to draw a line backwards, right? The line connecting the 2 points, and we're going to extend it past that point, right? Right. So check this, right? What that blue line does is it cuts the 205 angle into 2 pieces, right? It cuts it into a, okay. Yeah. It cuts it into a green, this green piece here, which is actually 180 because that's the angle in a straight line, and it cuts it in also into this orange piece on top here. Now the orange, you can't really see the orange too close to that thing. Let's get a darker purple. Right, the darker purple, right? So that darker purple piece corresponds to this angle here. So if you could find this angle here, you could find the one down there. And if you think about it, the whole angle is 205, and we know the green portion. You know what? Let's just color in the rest of the green portion. Oh, sorry. Right, the green portion It's 180, not so? Right. So if you just take 180 from 205, you get 25. Sorry, one sec. Right. So not 280, it's 205, Christopher. Right. So 205 degrees minus 180 is 25 degrees. Right. So that's correct. Yeah. The 360 minus the 205 would give us this angle here. Yeah. So you could do that too. 360 minus 205 would give us was that 155? And then this angle on top of here is also 180. So you can subtract 155 from 180. All right. So 180 degrees minus 155 is equal to 25. So that's if you go to on the flip side. And both of those methods are perfectly correct. All right. Okay, cool. Right. So yeah. So again, the working, of course, the diagram and the explanation thereof is a bit more helpful than just a shortcut across here, right? So I would always admit that. Okay. So that's the bearing of S from P is 25 degrees. Okay. So my Google Meet people, so Aisha, D'Angelo, Donovan, Julie, Liam, and Logan. If you guys are good with that, just kindly give me a quick G in the chat. Right? If you need me to re-explain, it's not a problem. I'm happy to do so, but you let me know. Oh, okay. All right. And in class, people, we okay with this piece here? Any questions? Anybody? Anything? Zero, you got that? All right, cool. But did you get it? Okay. All right. Okay, so we're on to the last question on the paper. What I'll do is I'll zoom in and I'll give you guys a couple minutes to kind of try it out. You know what? Let's zoom in. We'll do it one at a time. All right. So if you're not sure how to find the determinant, I'll give you a little hint, right? So if you have a matrix which just has elements, so a 2 by 2 matrix which has elements A, B, C, D, right? Let's just call that matrix A. To find the determinant of A, which can be written like that, or just determinant of A, what you do is you multiply A by D and you minus B by C. And they're telling you that this is equal to 24, right? So this would be the A by D, and that would be the B by the C. Right, so go from there. Can you do it over? I'm just joining. Could you go over, please? Sorry, guys. I just yeah.
Okay. So there's a proof f of x is this, g of x is this. They wanted you to show that f of g of 2, which is here, is equal to minus 3 over 13.
Right.
So I try to substitute 2 into this because initially when I just put off into this doesn't give me
Let me see. Prove that fg is equal to what?
Fg
of 2
is equal to negative
minus 13?
negative 3 over 13. Sorry.
Negative 3 over 13. Okay. So 2x plus 1 over 3x plus 1. So are we sure that the functions are correct?
Yeah.
Okay. So fg of 2. So 2 by 2 is 4. 4 plus 1 is 5. 3 by 2 is 6 plus 4 is 10. 5 over 10 is a half. Now a half minus 2 is minus 1.5, which is minus 3 over 2. And then 3 by a half plus 5, that's 1.5, is 6.5. So if you have minus 1.5, that's minus 3 over 2 by, what did I say? 1.5 plus 5. No, that is 13 over 2. Yeah.
Oh wait, no, it works out. I just didn't work out.
Yeah.
Okay.
After this, can we do some more circle theorem and fun? Okay, so hold on. Let me just go back up to a couple people who, right? So Goofia Productions and Okinat. Yeah, sorry. What you can do actually, the live is up on YouTube after class, so you can go into the live at about the 4th. I would say maybe like the 55-minute mark, right? And you can check it there. It's on YouTube right now. You can go on YouTube right now on the same adaptation, and you can always pull the slider to wherever you want to see it, right? Leading to non-leading, leading diagonal, and then non-leading. Okay, yeah. Right, I'll just give you some more questions. We can see. Maybe not tonight. I'm actually trying to finish a little bit tonight. to get home to help my wife with the kids. Because I leave at 8 o'clock and I finish at 8:30. Um, I do like to do simple geometry. Functions. Actually, one of the girls here working functions. So yeah, we'll take a look now. How to do some topics. So yeah, so I might switch my approach week after. Depends. Okay, so let's plug up some stuff here and see what we get, right? So we're gonna have 6 by minus v, then minus 2v by minus 5, and that's equal to 24. So 6 by minus v is minus 6v. That's going to give us minus 10v. Now, when you minus a minus, you get a plus. So you have minus 6v plus 10v. That's equal to 24. This is the same as 10v minus 6v. That's equal to 4v. And if 4 multiplied by v is 24, to solve for v, we could divide by 4. And whatever happens on one side of an equation must happen on the next side. 4 is cancelled, and v is equal to 6. Hey, thanks for sharing the live. Appreciate it. I have 14 tonight, boy, 13. Wow. That's real cool, guy. Hey, Shania, good to see you. All right. Google Meet, just give me a quick G if you go with part A, and we're going to go down to part B one time. All right, cool. All right, lovely. All right, so the matrices L and M are defined as follows. L is that, so we have here a 2 by 2 matrix, and here we have a 2 by 1 matrix. Evaluate each of the following. So the matrix product LM, and I guess the next part is as well. And then L inverse. So they want the product LM and then L inverse. Okay. So let's go first. So I'll give you a couple of minutes to sort out the matrix product, but I'll just write it out. I'll write out the question in the meantime, right? All right. So we have 9, 5, 3, 2, then by 2 minus 4. All right. Wow. Lost. Wait, did I cross 5,400 people? Hey, what day and time do you go live? I don't know what it is. Monday and Wednesday. PUA is from 4 to 6. Maths is from 6 to 8:30 or thereabouts. I usually start a little late. But yeah. Saturdays I have a CAPE accounting class 10 to 12, unit 2. So if you're doing CAPE accounting, you can tell them about it. Used to do the AdMats, but the AdMats got a little shifted. So the live's not going up right now. Yes, sorry? Oh. Yeah, but the lives do stay up very long. So if you all want to see lives, you gotta tune in. Oh, okay. Oh, wow. Okay. Okay, that is amazing. Right. So if you can't remember how to multiply matrices, let me give you a little help out here, right? So what we do is we actually have to multiply row by column. What does that mean? We have to multiply the horizontal by the vertical and the corresponding elements. So the first elements are multiplied together, as are the second elements, but those products are then added. So we have 9 by 2 plus 5 by minus 4. And then we do the second row by the same column here. And the same thing, corresponding elements, 3 by the 2, and then the 2 by the minus 4. 3 by 2 plus 2 by minus 4. right? So 9 by 2 is 18. 5 by 4 is minus 20. Of course, if you add a minus, you just end up subtracting. 3 by 2 is 6. And of course, you have a minus 8 here as well. All right, cool. So 18 minus 20 will just give us minus 2. And 6 minus 8 will also give us minus 2. All right, in class, people, are we okay with B part 1? Minus 2, minus 2. Yeah? Ladies, we okay with that? Yeah? Sian, what about you? You okay with that one? All right. All right, Google Meet, you know the drill. If you guys are good with that, just kind of give me a G in the chat. Somebody jump out. G, all right, lovely. Okay. Of course, if you have any questions, let me know. If you need me to re-explain me R, right? Okay. Now the next thing they ask us for is L inverse. Now what was L? L was 9. It was 9532. 9532. Okay. Let me write over L on this side here. Right. So just to help you a little bit if you need it, right? If you have a matrix A, B, C, D, let's call it matrix A. To find A inverse, you have to put 1 over the determinant, which again is A multiplied by D minus B multiplied by C. And then you multiply by what we call the adjoint of the matrix. Right? And the adjoint is simply a rearranging and modification of the values inside. So we actually swap, items on the lead diagonal, the primary diagonal, and we change the signs of the items on the secondary diagonal or the non-leading diagonal. All right. So I'll give you a minute or two to sort it out. Right. Oh, I got a question. No? All right. Osman Ashish. Pretty cool name. Huh. What does Eunice say? Uh-huh. Live streaming tournament. Okay, I saw that. Okay. Live stream schedule. Monday gone already. Tuesday. 8 a.m. is what time am I going? 12 p.m. L. Okay. 7 a.m. That's 12. I could do 12 on Friday. I do 5 on Wednesday and Thursday. All right. Well, what are we going to do? All right. Let's go from here. Right. So that's L. So L inverse. Right. So we're going to put 1 over. All right. So the product of 9 by 2 minus the product of 5 by 3. Then multiply by. So we're swapping out 2 and the 9. And the 5 and the 3 take the opposite sign. You could just simply multiply each of them by minus 1. 9 by 2, as you know, is 18. 5 by 3 is, 15. 18 minus 15 is 3. So you can put this as 1/3, then multiplied by 2 minus 5 minus 3, 9. I see no need to put that inside, but basically what you then do is you multiply that. That's called a scalar. It's like a coefficient to the bracket, and you multiply by each of the elements on the inside. Right? So 1/3 by 2 will just give us 2/3. 1/3 by minus 5 is minus 5/3. 1/3 by minus 3 is minus 1. 1/3 by 9 is 3. Right? Either of these is acceptable. You don't have to put this one. Okay. Right. Google Meet. If you guys are good with that, just kind of give me a quick Genie chat. Hey Priya, how are you doing? Thanks for the follow. We find it beneficial. Nia and Tahira. Oh, thanks for sharing. All right. Donovan, Liam, Logan, D'Angelo, Aisha. How about you? Oh, yeah, Julie. Oh, it's Julie. Okay, good. Well, I told Julie she could go if she wasn't feeling well. Yeah, maybe she sent me a WhatsApp because my WhatsApp's not coming through. So I gotta keep checking back on me. Oh, I'll send a couple more pics. All right. Yeah, so she did send a WhatsApp. All right. Yes. ID. Yeah. Mhm. Okay, no problem. That's fine. All right, cool. So we're going again. No, we had one more on that page to go. All right, so we switch to vectors now. Okay. Right, so PQ is a vector. Oh, come on, man, Philip. And this vector has components, right? Right. So your horizontal component is 5, your vertical is -4, right? What that means is that your vector, to go from point P to point Q, you have to go right 5 times. That's the horizontal component. Positive horizontals mean you're going to the right. And then -4 means you're going down 4 times. So Q is there. Right? So that's what a vector is. A vector is literally directions, how we get from one point to the next. All right? Give me 1 second. I'm going to just type the response here. Okay. Right, so right. So if the point P is -2, 3, determine the coordinates of Q. Right. So literally all you have to do. So if we start off here, right? So remember, this is the X coordinate, which is the horizontal. This is the Y coordinate, which is the vertical. So we're shifting 5 spaces to the right, which means you're adding it to that. And then we're shifting 4 spaces down, which means you're subtracting 4, right? So basically what we're going to do, right? So P, we could turn point P into what we call a position vector. A position vector is a vector that starts at the origin, hence we have the O. And all we're going to do is just shift this to -2, 3 on the vertical, right? And then therefore what we're going to do, right, is we're going to take OP and we're going to add PQ. And what that's going to do is it's going to give us the coordinates of Q, or how to get to Q from O, right? The middle letters are the same, and then when you add those together, they kind of cancel out, right? So you have -2, 3, and then PQ is 5 -4. So -2 plus 5 is same as 5 minus 2, which is 3, and then 3 minus 4 is simply -1, right? Now this is the position vector OQ. They wanted the coordinates of Q, so you therefore need to just kind of, like how we change the coordinates into the position vector, we just do in reverse now. So the coordinates of Q will simply be 3 and -1. Right? All right. Google Meet, you know the drill. If you guys are good with that one, just give me a quick Genie chat. If you need me to re-explain, not a problem. Let me know. All right. All right. So, yeah, we okay with that one there? All right. Aiden and no, sorry. Yeah. All right. 1, 2, 3, 4, 5. All right, cool. Okay, so let's go on to 10 part D now. Right, so 10 part D is a slightly more fun one as we have a diagram. All right, let's just take a little read through and I'll give you guys a couple minutes to try these two things here. All right, so let's take a read. In the pentagon OABCD, right? OA is parallel to DC. So OA is this line here, and DC is this line here. And we can see by the single arrowhead on those two lines that they are mutually parallel, right? And also AB is parallel to OD. So AB is parallel to OD, as we could see by the double arrowheads on them, okay? Okay, now what does that mean? Well, in vector speak, it simply means that that OA and DC are connected via a scalar. All right, we could clearly see that OA is longer than DC. So it means that OA, right, is equal to some constant multiplied by vector DC. It could be 2, it's probably 2, right? Maybe 1.5, who knows, right? Okay, but what is going on with this thing? I don't need any AI thing right now. Thanks very much, right? Sorry, so it says here OD is double AB. OD is double AB. Right, look, the vector along AB is just small b, right? So small b is the vector. So instead of giving us a horizontal and vertical, like they did in the previous part of the question, right? So instead of giving us some looking like this, they just gave us a horizontal, a common letter, right? So it's like vector algebra. That's not actually correct, but it's like algebra instead of that, right? So what it's saying is that OD is 2 times that. So if this is B, just plain old B, and this is 2 times that, the vector along OD would simply be 2 times B. Similarly, it says here OA is 2 times DC. Remember I was saying that? So OA is 2 times DC. Aha! Now they went the reverse here. But you say, but Chris, it's the same too, right? But OA is double this. And this time they gave us the vector of the bigger one, which is A. So if OA is 2 times DC, to find DC, you have to divide by 2. So it means that DC is actually a half of OA. Right? Let's just say this was a 4. This is 2 times that. So therefore this would be 2. All right? So this here is simply A over 2 or a half A. All right. So now that I've done a little piece with, sorry, why algebra half things? I guarantee I will do better with algebra. So I understand your frustration, right? It can be a bit difficult to wrap your mind around, and I totally understand. I used to have a lot of trouble with it, right? But you had to kind of shift your mindset about it. How to do that exactly, I can't get into right now. I want to just try and finish the paper tonight, right? But I will try and address it a little bit, right? Because I think it's beneficial for everyone to hear. All right, so they want 2 things, AD and BC, right? So I'm just going to write that here, AD and BC. Right, so I'm going to give you guys a few minutes for those who may know what to do and don't really want to just watch me do it, who may want to try it on their own. All right, so you have to find AD and BC, and there's one more part. State the conclusion about the magnitude of AD and magnitude of BC that can be drawn from responses. Okay, we'll come back to that piece. All right. Oh, hey Persia, how you doing? And Emily. Right. I know it's not algebra, but just saying, yeah, I hear you. Right, so you have to remember that mathematics is about the study of patterns, and algebra is part of the abstract thought part of it, right? So it's about thinking about concepts and how things work, and again, using the unknowns as like a representative of the unknown to be able to solve problems where we have unknown elements. Right, so it is a mental exercise, right? Right, we think of math as a science, and the thing is, math used to be considered an art at a point in time, and to a certain extent, it still is, right? I know I'm not doing it real justice here, or even probably helping that much, but what I'm saying is what passes for mathematics education is not really real. It's like saying that real food exists in like KFC or Pizza Hut. That's not really real food. It's food, you can eat it, but if you subsist on a diet of that, you're probably not going to be very healthy, right? It's not, I don't mean to battle KFC pizza. I eat those things. I didn't have KFC today, although I shouldn't have. Yeah, I definitely shouldn't have. But yeah, so the trick is to find where it has good food, right? Metaphorically speaking, of course. You know, so that could be tricky. And again, if you have a bad experience with it before, you might even really want to go looking for it, right? You might just try different diets or whatever. And yeah, not everybody needs to study maths to high levels. There's no necessity for that, but it's important to be able to think abstractly, to play with concepts, and you can do that using different things, not just mathematics. But mathematics is pretty nice if you have the right chef. right? And I would encourage you to read different. I mean, to read some of the books I've read. They're not very high level, but you still have to have a fundamental understanding of certain bits and pieces that maths helped me with. You know, so I think one of the things I really want to do is make maths a little more accessible to a lot of people. People bad talk sine, cosine, and tan all the time, but there's a reason for it, and the quote unquote discovery of it and the things they did with it were pretty interesting. I think it's like someone should do like a Netflix series about it. You know, but anyhow, but then I'm a correct question there before I go off on a whole, no pun intended, but a whole tangent. Yeah, I had 30 something on the line. Wow, I have glasses. Where did that come from? Okay. All right, guys. So sorry about my little rant there. Okay. Okay. Basically, what they're asking for here with AD is they want to know, in terms of A and B, right? How do we get from A, this point here, point A, to point D, right? And like I keep telling you, just think of vectors as directions, right? So basically, what we want to do, and we can only travel along the lines that have vectors on them. Now, the shortest way to go from A to D, right? Right, now that arrow isn't, oh, sorry, it should really be like a solid arrow. Okay, cool. All right, how are you doing? All right, so tomorrow we have them boys. All right, cool. Yeah, because it's 110. I'll have to keep track of, yeah. Yeah. Right. So it looks like the easiest thing would be to go from A to B, B to C, and then C to D, right? So we have a vector from A to B, that's just B, right? We do not, however, have a vector from B to C. And then the vector from C to D. So, right, so this here, if you look at the direction here, DC is going this way. We want to go this way. And the easiest way to do it is simply to do what we call inverting the vector, right? So DC is equal to a half A. We want CD, right? CD is the inverse of DC. And that's what the minus sign in front of it means. It simply means we are reversing the way. Do you do random questions or a particular order? Yeah, so I started with Jan 2025 and just working backwards, doing papers until we reach the exam. So we're hoping to get through all the 2021s before that. Right. So CD is just simply minus DC, or the inverse. So the vector along CD would just be minus a half A. But same thing, we're missing that piece in the middle, right? So we have B plus, well, we don't know, and then minus a half A. So that doesn't really help, right? But instead of going A to B, B to C, and then C to D, what about if we went in the opposite direction? What about if we went from A to O and then O to D? We actually do have vectors along both of those. The vector along this line is A, and the vector along this line is 2B, right? So alternatively, AD, actually, I'm going to just scroll along a little bit, right? Right? Sorry. All right. So AD is also equal to AO plus OD, right? Now again, look at the direction that we want to go. We want to go from A to O. The direction of this vector is is opposite to how we want to go. So we want to go opposite to A, right? In the opposite direction. So what we have to do is invert the vector, right? So AO is equal to the opposite or inverse of OA. And all we have to do is put a minus sign in front of it, right? This is equal to minus OA plus OD, right? So that's simply equal to minus A plus 2B, which you could also write as 2B minus A. All right? Oops. Okay, so can I just get a quick G in the chat, Google Meet, if you guys are good with AD, please answer. If you need me to re-explain, it's not a problem, but tell me, put the R, so I could go over it one more time if you need me to do so. Hey, Shona. Thanks for responding. Appreciate it. Right. D'Angelo, Liam, Donovan. Right. So what about and Luga? You all right with that? What is that? YouTube, sorry. Message. Dimitri, yes. 9 by 2 plus 5. Yep, that's Dimitri. Yeah, that's good. This. Oh, all right. Right. Okay. Let's put a little separator line here. And now we want to work out BC. All right. So they actually want us to get a vector to go from point B to point C, right? That way. Right. Yeah, drawing arrowheads is the bane of my existence. Okay, so let's take off some of these little extra annotations we have here, right? Just to kind of clear it up a little bit. You know, I should have just copy and paste the page because those annotations are actually pretty useful. So let me do that now. So let's do sitting at the same time. All right. Copy. All right. So on this one, I'll do the erasing, right? So hold on. Hold that. Right. Okay. Cool. Right. So to go from B to C. Right. Well, actually, it's easier than it looks. Right. But we only have one way to go. We got to go from B to A to O to D, and then D to C. Right. So this is a half A on this side. Right. This is 2B down here. Right. So BC is actually equal to BA plus AO plus OD plus DC. Right. Now, just a quick point of observation. We have that across here already. So you could actually shorten this to BA plus AD plus DC. You could. You don't have to, but you could. All right. Okay. So let's get this one done. Right. So why did I erase? Yeah, that's fine. Don't need that piece. Right. So to go from B to A, we are traveling backwards along the line AB and in the opposite direction of the vector along AB. So we have to invert the vector AB. All right. We are traveling in the same direction as AD and then DC. Yeah, we're traveling in that same direction. So we just have to put that DC. Okay, cool. So the inverse of B is just minus B. So we have minus B plus 2B minus A. And then the DC is plus a half A. So minus B plus 2B is the same as 2B minus B. And 2B minus B is just 1B. And minus A plus a half A. So 1 minus a half is minus a half. All right. Okay. All right. So Google Meet, just give me a quick G in the chat if you go with the part in the blue, please and thanks. Actually, I'm Donovan. So, right, D'Angelo and Logan. Right. Shona, thanks. Thanks. All right. Okay. Now, they ask us something on the very last page here about state the conclusion about the magnitude of AD and BC that can be drawn from your responses in part 2. Right? Now, you could go and work out the magnitude, right? To work out the magnitude, what you have to do is basically like a Pythagoras theorem thing, right? Now, we don't have to actually work the magnitudes out, and I'll tell you why, right? So, basically, we take the coefficient squared plus, so the understood coefficient. So, if no coefficient is explicit, what number is understood? 1, right? Right, so that's 4 plus 1. So that's root 5. You don't have to actually plug it into your calculator to find square root, right? Now, for the other one here, this is square root of 1. Sorry, the square of 1 plus the square of minus a half. So that's 1 plus a quarter. Yeah. Which is actually the root of 5 over 4. Which is the square root of 5 over the square root of 4. Square root of 4 is 2, right? And this is the same as a half of root 5. So this here is a half of this. Or you can say that this is 2 times that. Right? And the thing is, you didn't need to actually find the magnitude. You could have seen that from here. If you look at it, 2 is 2 times 1. Yeah. Okay. Yeah. And there's a 1 here. And 1 is 2 times a half. Right? It's actually minus 1. Right? So we could conclude here very easily that AD, right? Steady conclusion that can be drawn about is equal to 2 times BC, or BC is equal to a half of AD. Right? And you could also say that AD and BC are parallel. Right? We know this because once a scalar relationship exists between the functions, as in when one function is some number times the other function, hey man, I'll see you Wednesday, right? That's called a scalar relationship. And once a scalar relationship exists, the vectors are parallel. Alright? So just to sorry. Right. Just to kind of drive it home, what I'm saying is that so AD is this line here. And if you look at it in comparison to BC, it does look parallel. I mean, the diagrams are not drawn to scale, so we can't just assume based on the diagram, right? But, I mean, it does look that way, right? But the calculations bear it out, okay? So again, AD is equal to 2 times BC, or BC is a half of AD, and therefore AD and BC are parallel. But they were more asking about, you see these 2 little vertical strokes here in front, that contain the vector? That's talking about the magnitude. Magnitude of the vector is the size or length of the vector, right? So the parallel part isn't actually necessary in the context of what they ask, right? Right, so it's just this piece here, right? And with that, we've come to the end of the May 2024 Maths Paper 2, right? So next up on the agenda is Jan 2024. Right, so when we come on Wednesday, again, I'll endeavor to start on time and to have the papers printed, right? And of course, I'll send it in the chat so those at home can print it out before if they want, right? So we're going to try to do as much as we can on that Wednesday. I mean, I know it's Carnival week, so I know some people may not be here, but if you're not here, that's not a problem. Just watch your replay. Next week, after Wednesday, I intend to have class, right? So we are on that assumption. Yeah, well, you're home whole day. Right. So cleanse in the morning and come to class in the evening. Unless you're going to stay in church whole day and night. That's your business. If you're doing so cool, watch your replay. I will be here. I'll try and get my ashes in the morning. Right. Anyhow. So Google Meet. That's about it for today. If you have any questions and you get to ask during class, please feel free to message me. So now pick my WhatsApp not working so well, so I have to check WhatsApp to see if I get messages. I don't know why. Right? If anybody have any suggestions, apart from restart or check on the settings, I do all already. Nothing working. So it might just be the age of the phone, because I have a phone since 2018. Anyhow, so Google Meet, I'll go on there. I'll see you guys on Wednesday. Bye. Okay. Right. So yeah, sorry. So YouTube. Yeah, sorry. I don't be checking my comments here, because I had to kind of pay attention to my class now, you know. I have the TikTok on a separate laptop, so that's why I can see them a lot more clearly than you all. So I do apologize. It's not that I don't like audio. YouTube is where I can start, you know. So anyhow, and TikTok. That's about it for today. All right. So if you're found it helpful. You know, I appreciate the follows, I appreciate the shares, the likes. You could follow me on Instagram and YouTube as well. Right? I'm kind of more known for POA, but I do maths as you can see, and add maths as well. But yeah, maths a little on hiatus for now. But it will be back sooner rather than later. I'm trying to work at it, right? When next are going live? So today is what? Monday, so Wednesday. Wednesday 4 to 6 is POA, and then 6:30 to 8:30 is maths. And we start in the Jan 2024 paper 2 on that day. Right? It will continue next week, because of course Monday is carnival, so we're not doing anything on Monday. Wednesday, we're back at it. And then we're going to continue that way until the exam. We started with Jan 2025, and we're just working backwards as far as possible as we can go. Right? So sometimes the papers take 2 days, sometimes it takes 3 days. This one took 4. Because sometimes just have little technical difficulties as I end up starting late. That's life, you know. Anyhow, but guys, thanks very much for the but for this has been the most number of people that have been on a live. 30-something people, that's great. I hope you guys benefited. And again, the live is up on YouTube. You can follow me on YouTube too. Right? The lives are up there for at least the next 48 hours. Right? So you can always go through it and see the explanations. I think I have the previous lives there as well. But I'm gonna change them from public to unlisted probably by Wednesday. Because I had to close off some stuff. I have too many open things. Anyhow, folks, good night. I'll see you guys next time. Bye. Yeah. As you come back out from school, that is it. That week?
Yeah.
About our life. Let me go and get that thing here, right?